Alright, so in this video, I'm going to be proving to you guys that pi is equal to 3. So as you guys probably already know, pi is an irrational number, meaning it doesn't have a whole number value, and it's actually equal to 3.14159 and on and so forth forever. So that's why it's an irrational number. It's that just don't stop going. So in this video, I'm going to be proving to you guys that pi is actually equal to 3 and not the irrational number that we all know it is. So what I'm first going to do is start with the statement x is equal to pi plus 3 over 2. So all I'm doing is I'm giving a value to a variable, which is completely legal. So now what I'm going to do is multiply both sides by 2. So I get 2 times x is equal to pi plus 3 over 2 times 2. Now, 2 times x is equal to 2x. So I get 2x is equal to, these two 2's cancel out, pi plus 3. So I get 2x is equal to pi plus 3. And now, from here, I'm going to multiply both sides by pi minus 3. So I have pi minus 3 times 2x is equal to pi plus 3 times pi minus 3. Now, pi plus 3 times pi minus 3, I'm going to distribute the pi, so I get pi squared plus 3 pi minus 3 pi, which they just simply cancel out, plus 3 pi minus 3 pi. These two cancel out. And then I have minus 9 at the end. So this is, I can just say this is pi squared minus 9. And for my left-hand side, I can distribute the 2x, so I get 2x pi minus 6x. And now from here, I'm going to add x squared on both sides. So I have x squared plus 2x pi minus 6x is equal to pi squared minus 9 plus x squared. And let me just reorder this real quick. I'm going to write this as x squared minus 6x plus 9. So I'm going to add 9 on both sides. Is equal to x squared minus 2 pi x. So I'm going to subtract 2 pi x on both sides. And at the end, plus pi squared. So I have x squared minus 6x plus 9 is equal to x squared minus 2 pi x plus pi squared. And now, x squared minus 6x plus 9, this factors out into x minus 3 squared. And x squared minus 2 pi x plus pi squared is the same thing as x minus pi squared. So I have x minus 3 squared is equal to x minus pi squared. And now, I want to cancel these two squares, so I'm going to take the square root on both sides. So now the square root of x minus 3 squared is equal to x minus 3. And the square root of x minus pi squared is equal to x minus pi. So I get x minus 3 is equal to x minus pi. So now I'm going to cancel these two x's out by subtracting x on both sides. So now I get negative 3 is equal to negative pi. And now if I multiply both sides by negative 1, I get pi is equal to 3. So there you have it. I just proved that pi is equal to 3. So now where did I go wrong? Because obviously we know that pi is not equal to 3. So where did I go wrong? Well, I actually went wrong on this step right here, where I said that the square root of x minus 3 squared and the square root of x minus pi squared is equal to x minus 3 and x minus pi respectively. Well, this is actually not true. the square root of x minus 3 squared isn't equal to x minus 3, is equal to the absolute value of x minus 3. And same goes with the square root of x minus pi squared. It's not equal to x minus pi. It's equal to the absolute value of x minus pi. So the reason this is so important is because now I get x minus 3 is equal to negative x minus pi. Or also negative x minus 3 is equal to positive x minus pi, since we're taking the absolute value of these two. So if we want to solve x minus 3 is equal to negative x minus pi, we're going to have to first distribute the negative sign. So I get x minus 3 is equal to negative x plus pi. So now if I add x on both sides, these two cancel out. So I get 2x is equal to 3 plus pi. And x is equal to 3 plus pi over 2, which, going back, is what we started with. So there you have it. That is something really important to know, that the absolute value is, the square root of a square isn't just the normal version, it's the absolute value of that. Alright, so in this video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 8 minus 121 is equal to 0. Now, what most people would think to do to solve this equation is add 121 on both sides. So then I would get x to the power of 8 equals 121. And then, since x is to the power of 8, take the 8th root on both sides to get an answer of the 8th root of 121. And this method is actually wrong because there are actually many more solutions than just 2 to this equation. There's many more. So we want to find all of these solutions to this equation. So how are we going to do that? Well, our first step is to rewrite x to the power of 8 as x to the power of 4 times 2. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2 is equal to x to the power of 4 to the power of 2. Now I have this minus 121, which we can rewrite as 11 to the power of 2. And the reason we're going to do that is so now we can use an important algebraic property that states that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x to the power of 4 and b is 11. So I get x to the power of 4 plus 11 times x to the power of 4 minus 11, which is equal to 0. Now, from here, I get two equations. I get x to the power of 4 plus 11 is equal to 0, and x to the power of 4 minus 11 is equal to 0. And we are still not done yet, because to solve this equation, people are going to think, oh, add 11 on both sides and take the 4th root. But we're going to do the same thing we did with our original equation. I'm going to rewrite x to the power of 4 as x to the power of 2 times 2. And now I can rewrite that as x to the power of 2 to the power of 2. And 11, I'm going to rewrite as the square root of 11 squared. So now I can use this property again. So I get x squared plus the square root of 11 times x squared minus the square root of 11 is equal to 0. And again, I get two equations. I get x squared plus the square root of 11 is equal to 0, and x squared minus the square root of 11 is equal to 0. Now, what I can do is, for x squared minus the square root of 11 equals 0, I'm going to add the square root of 11 on both sides. So then these two cancel out, and I get x squared is equal to square root of 11. And now if I take the square root on both sides, square root of x squared is x, and the square root of the square root of 11 is the fourth root of 11. This is positive or negative. Now for x squared plus the square root of 11 is equal to 0, I'm going to subtract the square root of 11 on both sides. So I get x squared is equal to negative square root of 11. So now I get the square root of x squared is equal to the square root of negative square root of 11. So the square root of x squared is x, and the square root of the negative square root of 11, I can rewrite this as negative square root of square root of 11. So now this is the same. So now if I take the square root on both sides, I get the square root of x squared is equal to negative square root of 11. Or sorry, the square root of negative square root of 11, which I can rewrite as x is equal to the square root of negative 11 to the power of 1/2, which is equal to negative 11 to the power of 1/2 to the power of 1/2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 1/2 times 1/2 is 1/4. So I get x is equal to negative 11 to the power of 1/4. Now going back here, I have x to the power 4 plus 11 equals 0, so I can subtract 11 on both sides, and I get x to the power 4 equals negative 11. Now I can take the fourth root on both sides, so I get x is equal to the fourth root of negative 11, and this is positive or negative.